hook you up. Is that okay? Yeah? Okay. So, good morning, everybody. What we're going to do this morning, you can tell that I'm very high because I drank 3 or 4 espressos. I have to wake up at 4 a.m. to get here. The consequences would be that I'm going to speak really fast, so slow me down, okay? Slow me down, that's okay. What I'm going to try and do today, hello, sorry, that's okay. I got a wonderful introduction from Santos. I'm going to try and do several things, but still in a structured way. Like Santos said, I think that there's a lot of questions about the terminology that we're using. We talked about this before, especially in our team, my awesome team, Team 5. There's a lot of confusion around the terminology. We use terms like adaptation, individualization, optimization, factorial designs. People talk a lot about MRTs. All kinds of terminologies are kind of floating around. And I'm going to try and define certain terms so we would have kind of a common understanding around what they mean, right? So that's the first thing I'm going to try and do. The second is I'm going to try and structure a little bit more the process of building an intervention package, a mobile-based intervention package. And I think this is important as well. And I think that another thing, well, the primary thing I'm going to do is to introduce you to 2 experimental designs, 2 factorial designs, and smart designs. And I'm going to show you how these 2 experimental approaches can help us construct high-quality intervention packages, okay? Now, I think that the most important thing I want you to get out of this talk, and I want you to know this when I describe the designs, is that before I describe the design, I always start with a scientific question, okay? And the reason I emphasize this is because I have a personal problem. We haven't started, and we already talked about my problems, but I have a personal problem, and I am a big fan of methodology, right? I'm a big freak. Now, what happens to me is that I get excited by methodology, by design, and then I'm trying to find the right scientific questions to justify the use of that particular design, right? But I don't think that this is a good scientific practice. I think it works the other way around. We always need to start with the scientific question, and I need you to keep in mind that sometimes very novel and interesting and significant scientific questions, they can end up being tested with a simple design. And that's completely okay, right? It's fine. The novelty is in the scientific questions that you're trying to address. Everybody with me? Okay, so here we go. Terminology. Many interventions, and I think that particularly mHealth interventions include multiple components. By the way, please ask questions during my presentation. Okay, I want this to be more of a discussion than a presentation. So many mHealth interventions include multiple components. What do I mean by component? What does it mean? Can you tell me what you think it means? Because you've been using this term for the past several days. What does it mean, a component? The definition is here, but I want you to tell me what you think it is. Yeah.
Active and
okay. Anybody else? Yeah. Okay. Any other? Yeah.
Functionality.
Okay. Interesting, but did you see different points of view about what a component is, right? So all of you are correct. Just for the sake of standardizing our communication, we tend to define a component as any aspect of the intervention that you can reasonably separate for study purposes, okay? So the content of your intervention can be a component. What mechanism you're trying to target, right? The modality that you're using to deliver the intervention can be a component. Are you using the internet? Are you using the mobile device? Right? And also components can be aspects or features that you're using to promote compliance, adherence, engagement, text messages, email reminders. Right? The best way to demonstrate this is with an example, and this example is based on the work of Barney Spring. And what Barney wanted to do is to develop and optimize a technology-based intervention for weight loss. And in the process of developing this intervention, Barney had multiple components in mind. See these 5 components? Telephone coaching, report to primary care provider about progress, text messages, meal replacement, and body training. This means that they train family members and friends to be supportive of weight loss. And we're going to use this example throughout. Now, you see, typically, let's talk about the process. Typically, when we want to design an intervention package and we have multiple components in mind, we tend to take what is called an evaluative approach to intervention development. And what does it mean? It means that we take an approach that involves 4 major steps, okay? In the first step, we establish our scientific model. And Donna talked about this. What does it mean? It means that we need to define our distal outcome. What is our distal outcome? Is the ultimate goal of our intervention, what we want the intervention to achieve at the end. And then we describe how and why changes in the distal outcome are expected to occur over time. This means that we need to specify our key factors and how they are related to each other, right? How they progress towards the distal outcome. Okay, and after we do that, and of course, we do this based on empirical evidence in our field, theories in our field, practical considerations, and so on. The next step is to identify our intervention components based on our scientific model. Right? And remember, the intervention components are designed to affect this process, right? To influence that process by which change in the distal outcome is expected to occur, right? Okay, so let's assume, just for the sake of this, conversation, that I identify the 5 components that I showed you earlier from Bonnie's study. Okay. What do I do next? Next, I construct an intervention package. What does it mean? It means that I take my intervention components, I put them together into an intervention package. Bonnie likes to call it the kitchen sink. Other people call it the black box. But basically, you integrate everything, and then you have a package. Very nice. Then you move on to the 4th step. This is why we call it the confirmatory, the evaluative approach to intervention development, because you move straight to the 4th step, where you take your intervention package and you compare it to control to confirm its effectiveness. So far, so good? Yeah? This all looks very familiar. So now you're wondering, what is the problem? What is the problem? Okay, my personal problem, again, is that in many cases, I have many open questions here in step 3 that prevent me from developing a high-quality intervention package. You see, sometimes I have questions about the effectiveness or efficacy of individual components. For example, sometimes I don't know which components are effective and which are not. It's possible that text messages based on literature is effective for young adults, but say that I want to develop an intervention for older adults. I don't know if text messages will be effective for this population. It's an open question. Sometimes I don't know which level of the component is most appropriate. Should I provide several text messages a day, or maybe one would be sufficient, right? So here the question is about intensity. And sometimes we don't know which components work well together and which do not. You see, it's possible that text messages would work really nicely with meal replacement, but text messages and coaching would be too much. It would be too burdensome. Maybe, I don't know. Sometimes we have open questions about how to sequence and adapt our intervention components over time. And this relates to the fact that many of us, myself included, are interested in developing adapting interventions. I'm going to define adapting interventions more formally later, but just for now. An adaptive intervention is an intervention in which the components are sequenced and adapted over time to address not only the unique needs, but also the changing needs of people as they progress through an intervention. There are many reasons to consider adaptive interventions, and I'll talk about this later. But in order to pull it off and develop a high-quality adaptive intervention, we need to know a lot of things a priori. Okay, for example, we need to know what to offer first. Should I start with text messages or maybe phone coaching? I don't know. What should I offer subsequently? If I start with text messages, what's next? Maybe meal replacement or phone coaching? I don't know. And this is really interesting. In many cases, we don't know what is the best way to tailor our components, so we will be able to address the changing needs of people properly. What do I mean, tailor? Tailor, I mean that we use information about people to decide what to do. to offer different components. So far, so good? So what is my point? My point is that in order to be able to develop a high quality package, we need to be able to answer all these questions before we take the package and compare it to control. And guess what? In many cases, we can. So the question is, what do we do? Today, we're going to talk about two experimental approaches. Factorial designs and SMART design. SMART stands for sequential multiple assignment randomized trial. I'll say it again later. Factorial designs, they're not new, okay? They've been here forever. But I think that their use for intervention in the context of intervention development is relatively novel. These designs can help us answer questions about the effectiveness of individual components. They can help us screen out efficiently multiple components and figure out which should be included in our intervention package and which should not. Okay? SMART designs, they are relatively novel. They were developed specifically to help us build high-quality adaptive interventions. They can help us figure out what is the best way to sequence and adapt our intervention components over time. So far, so good? It's just the intro. Let's start with factorial design. Okay, so like I said, factorial designs, they've been here forever. Everybody knows, what they are. But just for simplicity, and again, to have a common language, a factorial design, first of all, it's a randomized trial, okay? And keep in mind, both of the designs I'm going to talk about, involve between person randomization, not within person randomization. Many of you mentioned N of 1, MRTs, which is an integration between person and within person. Here, we're only going to focus on between person randomization. This means that people get randomized to different conditions, okay? The randomization is not within a person. So far, so good? Okay. So it involves randomization, and factorial designs typically involve, obviously, they involve more than one factor. And in these designs, the levels of each factor are crossed with the levels of the other factors to form a design with multiple experimental conditions. Okay, and let's see how this works. We always start with a scientific question. Okay, so let's assume that there are two questions that I need to answer that prevent me from developing a high-quality intervention package. I want to know, should I include text messages in my intervention? And should I include meal replacement? These are my motivating questions. To answer them, I'm going to include two factors in my design. One for each component. You see, the first factor is for text messages, and it will have two levels, on and off. On for people who will get text messages, and off for people who will not. The second factor will be for meal replacement, and again, it will have two levels. On for people who will get meal replacement, and off for people who will not. So far, so good? To answer both questions simultaneously, I'm going to consider this 2 by 2. What's wrong with you? It's dead.
Are you pointing it backwards?
No, not backwards, enough forward. You fix this and I'll fix it. Nothing's working. So why is it 2 by 2? It's a 2 by 2 because we take the two levels of text messages and the two levels of meal replacement, right? 2 by 2. We cross them. And this will give us a design with how many experimental conditions? How many? 4. Okay, you'll see that in a second. Hopefully. Or I'll have to demonstrate. Illustrate them.
You can use people and what they're like.
Oh, that would be wonderful.
You can announce it.
Yeah.
You can announce it. No, good idea.
And then, yeah.
So I have a question that I was going to wait.
Yeah.
By the end of this.
Yeah.
Enough time. Yeah. And I struggle with this every time
I know. I anticipated the question. I was like, yeah, okay, just go on with it.
Chicken or egg? So Bonnie factorial design after she had a successful intervention. Yeah, she wanted to figure out which of those components work.
Yeah.
And my immediate thinking is you should do the components first, but then when I do that, I think no, because the intervention first, and then see which of
and my answer is the same answer all the time.
Okay.
So that can you summarize and
Yeah. Okay, so there are two ways to think about disentangling your components. Okay, thinking about your components, about the process. Okay, one way would be to start with an intervention package that you already have, but it's not working so well, or it's not optimal, and you're saying to yourself, well, something's wrong here, or I need to optimize it. Let's disentangle. Let's break it apart and see which component is effective, right? And then you conduct tutorial design where you look at the efficacy or the effectiveness of each component. Okay, that's one way to do that. Another way to do this is to start with the scientific questions. To say, I want to put together a package. What do I need to know in order to put together a high quality package? Both directions make sense depending on where your science is. Okay, so in some cases, like in your case, you already have an intervention package and you want to optimize it, so you disentangle the components to test them individually. In Bonnie's case, she was trying to put together an intervention package, building on multiple components that haven't been put together before as a package. She wants to optimize that integration. Does it make sense? I think that, well, the truth is always in between, right? But I think that, here the truth is in the iteration, right? What does it mean? It means that intervention development is an iterative process where, say that you start by putting together your components, conducting several trials to figure out how to put them together, and then you run an RCT to see whether the package is better than control. And guess what? It's not optimal. It's not working for everybody. Some things not working quite well. So it makes sense to then go back to disentangling the components and figuring out again, or conducting experimentation to figure out which components shouldn't be included in intervention, right? Or how to optimize existing components in intervention. Does it make sense? It's a back and forth kind of process. Does it answer your question until the next time?
No.
Okay. Okay. We can talk about this again later. Yeah.
Here's like a related question.
Yeah.
So it's like sometimes like you have some data that you can run some secondary analysis on just to like form some hypothesis about like your hormone way of like
can you speak louder?
Yeah, so whatever
Or very summarize.
Yeah, go ahead.
or like you have to summarize.
Yeah, so I think that what you're asking, it's always better to ask the person who's different than someone. Tell me if I got this right, but you're asking, sometimes you use empirical evidence, like preliminary evidence, to identify certain components or to justify the inclusion of certain components in your intervention. And you're saying if there's a way to formalize that process. And I don't know if formalize is the right word, but the way it works, that's why I said that your scientific model is based on empirical evidence and theories in your field. This is how you identify the mechanisms that are likely to influence your proximal outcomes and that you can influence via intervention, right? So there are several ways to justify the inclusion of components. Some of them would be to say, look, this mechanism influences the distal outcome, so I need to design a component that influences that particular mechanism. That's a justification. And then, but if you had designed that component, do you know for sure that it's going to be effective? Then there's the process of conducting pilot studies. After developing a component, you say, okay, let's see if this component in itself works or shows some signs of effectiveness, of preliminary effectiveness.
Right? This is not like a factorial design. Right?
No, not really. These are just preliminary. Yeah.
It's just like one component.
You can do this for one component, but you can do this for several components. But I think that the process is that I'll give you an example from Bonnie. So phone coaching is a component in Bonnie's study. What she had done to convince her viewers in this round that this component has a chance of being effective, she had lots of preliminary evidence showing, first of all, what is the mechanism that this component is trying to target, right? And second, that there's potential for this component. She tried it before, she pilot tested it, feasibility, acceptability, some evidence that it would be effective, and then it makes sense to try it out in the context of figuring out whether it should be included in the intervention. Never try a component or suggest a component that you're not sure or you don't have, you're not convinced that it might work, right? If you think that a component is not effective, if you don't have enough evidence to justify its exclusion, don't even try and test it, right? It doesn't make any sense. You have to have the scientific justification for including a component in those particular studies. Does that make sense? Does it answer your question?
Yeah, let me push on this point, right? And let's talk about the nature of evidence that is generated. And what you're describing now in this chain, we're starting with the component, seems to me actually what needs to be extended far further before it goes back. Because honestly, when you do an RCT with a package of 5 components, and whatever the result is, actually, I don't know what to do with that evidence, right? It doesn't help me develop the next intervention, right? It doesn't help me, doesn't tell me how these things affect it seems so, and this connects to Donna's question. Starting with that as the first study, and then saying, well, it's not working quite right. Let's go back.
Yeah.
In terms of accumulation of science, scientific evidence seems better.
So let me correct what I said earlier because it looks like so this is really really important. Let me clarify this. I didn't say that in the process you should start with a package, compare it to control, and then disentangle if it's not effective. No, that's not what I meant. Sometimes in the literature, this is why I said it depends on where your science is. In my field, for example, there's a well-known intervention for alcohol use in college students. It's been used before several times. It's a package. Guess what? The effect size is relatively small. Now I'm at the point where I'm asking myself, it's there. It's considered the standard of care, but it's not as effective as we would hope that it would be. So what do we do now? In several studies, several grant applications, we try to disentangle the components. What this intervention includes so we can figure out which component is effective and how to optimize it. Does it answer your question?
Sure, but mHealth is a little different, right? Because most of the things that you're putting into mHealth intervention have actually not been tried yet. Because the implementation matters, the design of how you're packaging this piece of construct is going to change. So I don't think we actually have very many examples of that scenario that you just outlined. That we have this package that we think is kind of okay, but we want to do it now. You're actually starting with new components. Even if the mechanisms are well known, by the time you actually build it into an app, there's so much of this translation in terms of what the usability is like, what the user experience is like, that it's actually a new component. So in that context, trying to build up the evidence for those components means in terms of advancing the science, like the step that needs to happen first before bothering with NRC.
Yeah, see, I don't know. It depends on the field. See, because I think that, like, for example, in the case of alcohol use disorders, alcohol use in college students, there's a lot of work that went into designing these intervention packages that have been shown to be effective. So I don't think that we can dismiss all that and say, oh, I'm just going to throw it all away and I'm going to design something new, right? Because think about it. People have worked really hard on putting together the theoretical basis and also they have empirical evidence showing that they can be effective for some people, right? And they do produce effects in some cases. So I don't think that, in terms of scientific evolution, I think that we need to build on what is there. We need to develop new things, of course, but we also have to think about the process where people put a lot of effort into designing these interventions, and they are effective for some people. And the question is, what can we learn from these intervention packages that are already there? And can we disentangle? I agree with you. As soon as you disentangle the components and you try to optimize it, the components are essentially new. And even if you try it out in a different population and you adjust them for a different population, the components are already new. But I think that question, this is a question of semantics, right? It's a question, in terms of the process, how you describe the process, you build on existing evidence, existing packages in the field, and you ask yourself, is this effective enough? Can I use it in my specific case? If it's not effective enough, can I disentangle the components so I can optimize it? Does that make sense? I gotta move on.
That's what I'm going to say. This is philosophical discussion.
It's a very
your slides back up.
Yeah, thank you. But it is a philosophical question. But like I said, the truth is always in the middle, in the in-between. And it is an iterative process. Factorial design, 2 by 2. See, you said 4 conditions, makes perfect sense. Let's assume that I have 400 participants that I can include in the study. 400 is quite a lot. Naturally, what I will do is I will randomize these participants equally to each one of these 4 conditions. So I would have 100 in each participants in each condition. Does that make sense? What I want you to notice is that these 500 people will get everything, right? Both text messages and meal replacement. These people will get only text messages. These people will get only meal replacement. And these people, the poor people, will get nothing. Yeah? I personally want to be included in this group. Okay, so let's assume that I conducted the trial, collected my data. My outcome is weight loss at the end of the program. The question is, what do I do with the data to answer both scientific questions? And the answer to this question is by estimating main effects. Okay, so what are main effects? A main effect is the effect of a factor averaging over the levels of the other factors. Okay, so here the main effect of text messages can be estimated by pulling outcome information across all the conditions in which people got text messages and comparing it to the pulled outcome information across all the conditions in which people did not. You see that? It's like a 2-on comparison. Half of my sample, 200 people versus 200 people. Do you see that? Yes? The second question can be answered by estimating the main effect of meal replacement. This will be done by pulling outcome information across all the conditions in which people got meal replacement and comparing it to all the conditions in which they did not. Do you see that? Again, it's a comparison of half of my sample versus the other half. 200 versus 200, yes? Yeah? It's kind of cute, right? The fact that, think about it, me, okay? If I was a participant in the condition that I really wanted, here, 4, my outcome data would be used to answer both scientific questions. We use it twice. To answer this question and this question, to test both main effects. It's nice because think about a standard RCT. In a standard RCT, outcome information from one particular participant is being used to answer only one primary question. Is packaged better than control? Yes? Here, data from one participant is being used and reused to answer multiple scientific questions. This is known as the recycling feature of factorial design. But you see, the issue is that usually we don't have only 2 components that we want to screen out. We have more than that. Let's see what happens to the data when now I want to answer a third question. In addition to 1 and 2, I also want to know, should I include body training in my package? So what do? I have another factor for body training, and it will have 2 levels, on and off. On for people who will get body training, off for people who will not. So what do I have now? I have a 2 by 2 by 2 factorial, right? Because I'm crossing the 2 levels of text messages with the 2 levels of meal replacement, with the 2 levels of body training. This will give me a design with 8 experimental conditions. Say, wow, looks complex? Not really. Because let's assume that I have 400 participants, again, for the study. How do I answer each scientific question? By estimating what? The main effect. So how do I estimate the main effect of text messages with the data? Again, let's assume that I conducted the study and my primary outcome is weight loss at the end of the program. See what happens? I will pull outcome information across all the conditions in which people got text messages, and I will compare it to the pulled outcome information across all conditions in which people did not. You see what's going on here? Now, I have only 50 participants in each condition. See? Because I took my 400 and I randomized them equally to each experimental condition. So I have 50 participants in each condition. But still, this scientific question can be answered by pulling outcome information from half of my sample and comparing it to the other half. Yes? Same thing with meal replacement. Do you see that? I will compare half of the sample versus the other, 200 versus 200. Same thing with body training. So what's the bottom line? The bottom line here is that despite the fact that now I added another component that I want to screen out, so I have 3 questions instead of 2. Despite the fact that now I have a more complex design, some of you said, wow, when you saw the added experimental condition, and I have fewer participants in each condition, yes? Despite that, all else being equal, adding another factor, adding another scientific question, did not cause any loss of power for addressing these scientific questions, for testing these main effects. Does it make sense? What's going on here? Now, some of you might be thinking, well, this is nice, whatever, but she still doesn't have enough power to compare, say, the condition where everybody got where people got everything versus the condition which I want to be in where people got nothing. You see, how many of you were thinking like? How many were thinking, well, whatever main effect is nice, but she's by adding another component and making the design more complex, she's losing power for comparing individual conditions. How many of you were thinking like that? Come on, raise your hand. Come on. Yeah, thank you. I know you do. You always do. And I'm trying to convince her for the past 4 years. We'll see when this will happen. You are correct. You are. Because you see, here this comparison between everything on versus everything off would be based on comparing 50 participants and 50 participants. But here, it would be based on comparing 100 versus 100. Do you see that? Well, this is for you, Donna. This is something new that I added. So what's going on here? Do you remember my scientific questions? What were my scientific questions? I wanted to know whether I should include each one of these components in my model, in my package. Right? That's what I wanted to know. I did not want to know whether package is better than control. This is a comparison of the package versus control. Everything on versus everything off. I didn't have that question in my list. Right? This is why I keep going back to always start with the scientific question. My scientific questions concern the efficacy of individual components. I wanted to screen out the components because I didn't know whether a package would be better than control. I'm before that step of comparing the package to control. If this is concerning you, if you are very concerned that you're not going to have enough power for comparing this condition to this condition, this means that this is a primary scientific question that you need to consider when you design the study. You better size the study for addressing this scientific question if this is your primary scientific question, but then I suggest not going for factorial design, but going for an RCT, right? Does it make sense? Always start with your scientific question. That's the bottom line. SMART design. Okay, so SMART stands for sequential multiple assignment randomized trial. The reason why I always start with factorial design is because SMARTs are a form of factorial. SMART is a form of a factorial design. You'll see, it's really interesting. Okay, I said that these designs can help us build high-quality adaptive intervention, but we need to define an adaptive intervention first. I gave you like a broader definition. So what is an adaptive intervention? First of all, it's an intervention design. You see these words, intervention design? And the reason I emphasize it is because an adaptive intervention is not a trial. It does not have any randomization, and a lot of people find it really confusing, right? It's an intervention design. It guides how we should provide intervention, but we're not testing anything. This is not experimentation. SMART is the experimental design that can help us build adaptive intervention. And adaptive interventions, they describe how we should provide treatment. So far, so good? Okay, so what is an adaptive intervention? It's an intervention in which we use ongoing dynamic information about people, how they progress through the intervention, to make decisions about the intervention components, to decide which component to offer, when, and for whom. Okay. Again, an example, and this is kind of a funny example. I still call it a hypothetical example, but this is the first example that Bonnie and I started to play with 3 years ago. And this ended up, a different version of it, more complex, ended up being a funded R01 by NIDDK, and this was part of a mHealth training like this one, but only in the winter. It was really interesting. Anyway, so what's going on in this example? Not the training. The training wasn't depressing. The winter was depressing. Just to emphasize this. So here, I'm starting with, that was horrible, I know. We're starting with text messages, okay? Why starting with text messages? Again, the focus is on obesity treatment, right? Why do I start with text messages? Because it's a low-cost component, right? And we have evidence showing it can be relatively effective for some people. So we thought that this is a good start to provide text messages first. And then, see, this is interesting. At week 2, we assess whether participants respond to text messages or not. And why do we do that? We do that because although text messages are effective, we have empirical evidence showing that. Although text messages are effective to some extent for some people, many people do not benefit from text messages alone, right? Many people need more than that. And in fact, we have data from several studies showing that we can identify those people very early in the course of the program. We can identify them at week 2, people who, based on our data, people who do not lose enough weight, at least 1 pound by week 2 of a weight loss program that is based on mobile health, are highly likely to fail at the end of the program. Failing means not losing 5% of their body weight by month 6. See that? So our data shows that not losing 1 pound during the first 2 weeks of a text message-based treatment is highly predictive of failure at the end of the program. You see that? And if it is highly predictive of failure, we might as well do something for people who do not lose enough weight by week 2, right? This is why at week 2 we identify non-responders, and guess what we do? We augment. We add another component. We add body training. Family-based, friend-based social support, right? And then we take our responders, they're doing okay. And for them, we step down the intensity of the text messages. They're doing okay. There's no reason to burden them, right? Okay, so that's an adaptive intervention. Why is it adaptive? It is adaptive because we use information about response to text messages, progress in the course of the intervention, to decide what to do with the components. Do you see that? We use dynamics. This information is time changing. It happens during the treatment. We use it to decide what to do. Our tailoring variable, talk about definition. Tailoring variable is information about participants that we use to make decisions about the components, right? What is the tailoring variable here? What information do I use to decide what to do? The response status. You see? I use information about the participant's response status to decide whether I should augment with body training or step down the intervention. Do you see that? Adaptive interventions can be protocolized with decision rules. Protocolized so they can be replicated, right? This decision rule describes this adaptive intervention. At stage 1, provide text messages. Then, if non-response, augment with body training. Otherwise, step it down. So far, so good? Yeah.
Quick question. So, different decision of whether somebody is a responder or not responder, that also is not as trivial. It applied on a threshold, right? Responded to 5% of text messages, responded to 70% of the text messages.
Yeah.
So, is that something which is empirical? Is that something based on?
Yeah. So we use data analysis to we use our C curves, sensitivity and specificity, and those of you who are interested in learning about this later, to identify the best threshold of weight loss during the first 2 weeks that gives us the best sensitivity and specificity for failure to lose 5% of the body weight at the end of the program.
So you use the outcome.
Yeah.
To decide
the sensitivity and the specificity. And I can tell you that in this process, those of you who are interested, I can send you a really nice paper that was published a few years ago describing that procedure of using our C to to identify the thresholds for the tailoring variables. It's really nice. I can tell you that I've tried about 15 combinations, 15 thresholds for multiple combinations of variables, because we thought, just to give you a sense of it, we thought that the combination of weight loss and engagement in the text messages, that combination would be highly predictive of failure at the end of the program, but that wasn't the case. Consistently, we found that if you don't lose your weight loss during the first few weeks of a weight loss program, that's the best determinant of not being able to achieve the ultimate goals of the intervention, not being able to achieve the distal outcome. You see that? You all with me? Okay. So why do we need adaptive intervention? Yeah.
So you make that decision from data from separate stuff.
Yeah. So we had preliminary, this really goes back to your question. We had preliminary evidence from several studies in which people received text-based interventions for weight loss. And we used these studies to figure out what is the information that we can use from their early experiences in the program that is best predictive of failure at the end of the program. Does it make sense? This is because here we conceptualize the tailoring variable as a strong predictor of failure. If not losing enough weight by week 2 is a strong predictor of failure, it means that I need to do something for people who do not lose enough weight by week 2, otherwise they will fail. See that? That's why we augment the intervention for people who do not lose enough. We show early signs of non-response, and we do something else for responders. Does it make sense? Yeah? Okay. So why do we need adaptive intervention? The first justification actually relates to what I said earlier. You see what's going on in this example? This is based on evidence showing that there's high heterogeneity in response to text messages. High heterogeneity means that some people would benefit from this intervention component and some would not. Right? And there's high heterogeneity in response to pretty much any given treatment. Right? We know that what works for one person might not work for another. And in many cases, we can identify early those people who are likely to become ultimate non-responders, those who will not achieve our distal outcome. Here we can identify them very early in week 2. And if we can identify them, we should do something about it to prevent them from failing. You see, so that's one important justification for an adaptive intervention. That we can identify early those who are not responding, and we do something about it to prevent them from failing. So far, so good? But there are other justifications that I think that are highly relevant in the context of mHealth interventions. I want to share some of them with you. One is cost. We know that some mHealth components are more expensive than others. We know that. And by the way, sometimes the most expensive components are the most effective ones. And what can we do? We live in a world with limited resources, and if that's the case, we have a huge issue in terms of scalability. Our ability to ensure that the majority of the population will benefit from this intervention, right? That's why it makes sense to adopt a stepped care approach to intervention provision. What is a stepped care intervention? A stepped care intervention is an adaptive intervention that starts with minimal support. You provide the least expensive support, the least expensive component initially, and then you identify those who are not benefiting from the least expensive support. Still, it has to have a potential, right? Don't include a component that is not going to be effective. But we do identify those who are not benefiting from minimal support, and we add more expensive components, but only to those who need it, right? We can also identify those who are doing okay and step it down, provide less expensive support, less burdensome, reduce the scope or the intensity. You see, we step up and down the intensity, the scope, and the cost of the components so we can achieve a cost-effective intervention. Does that make sense? Okay. The second issue is boredom. And you see, this is funny. Wilmar Shafali, he called boredom the most understudied emotional state. And this is funny because we're all striving so hard to avoid being bored, you know? But we forget about it when we design interventions. You see, if you try and provide the same component over and over and over again to people, you're going to lose them. But you mentioned a study by Eric Heckler. Eric, like me, is obsessed by the idea of variability. Why? Because people get bored. You have to include variability in the components and monitor people to see if they show signs of boredom and modify the components, introduce new components, so people will stay engaged, right? Okay. The second is burden. I mean, this happens to me so many times. I go to a website, and this website includes so much information, so many components, so many mechanisms that intervention developers were trying to target at the same time. You know what happens to me? I shut it off, right? I turn it off. You can't pay attention to so much information. This is why it's important to sequence the components, introduce new components at a time, and monitor people to see if they show signs of excessive burden and tone down the intensity of the intervention, accommodate that, so people will not disappear on you, right? Yeah.
How do you monitor boredom or burden?
Oh, that's a good question. It's a good empirical. There are various ways to do that. There are various. We can talk about this later offline, but there are some measures that are more, well known in the field. Most of them are based on self-reports or observations, right? In the context of mHealth, it's a big question, right? Because what is burdensome for me might not be burdensome for you. And also there's a lot of issues around, say that, for example, you decide that if a person is not accessing the intervention, the mobile intervention for a week, that's a sign of burden, that it's too much for him, right? But is it really a sign of burden, or is it a sign of boredom, that the person is not interested, that the person is not with you, or is it a sign that the intervention is not effective, right? So the same measurement, right, tool can be used to make multiple inferences about the person's state or approach with regard to the intervention. So I think this is still a research question for how you measure burden, but I think that we're getting there. I think that it hasn't been completely validated. I think we're not there yet. But many interventions, many mobile interventions do acknowledge the fact that burden is a key issue, and they use both passive and self-report data to determine whether people are feeling excessive burden from the intervention or not. Yeah.
I'm just going to do a shout out to one of my colleagues, Julie Hines, at University of Washington. A paper come out for the user burden scale.
There are many others that are coming out just now, a few weeks ago. So that's what I'm saying. I think that we're getting there. What else did I want to say about? There's a lot of enthusiasm right now around the issue of measuring engagement and burden, right? But we need to keep in mind that they are related, right? So and it's true that many scales have been validated to be not many, but a few to measure properly burden. But I think that even then, it's not completely clear whether it's burden, or there's always the relationship between burden and engagement that is really difficult to disentangle. That's all I'm saying. Yeah.
I can make one proposal. I think boredom is sometimes good because like you are doing the same thing that it is you are intervening like topics that I'm already familiar with, that because I think like to just make the boredom kind of fun, that would be like a interesting strategy that completely changes strategy.
Right. Right. So this is an interesting discussion, again, a philosophical one, around the tension between consistency for habit formation and variability for reducing boredom and habituation, right? Because, on the one hand, habit formation is all around consistently introducing specific stimulus, expecting this consistent introduction to gradually lead people to form a habit, right? But on the other hand, people do get bored, but then, so you need to introduce some variability to, you call it, to make the boredom fun. And I call it like to balance out consistency and variability. Does it make sense? Anyway, yeah, so these are the reasons why we need to consider adaptive interventions, just to stimulate some thinking and motivate some thinking when you develop your projects. And now the question is, why do we need a SMART? But before we answer that question, I want to tell you more about what a SMART is, okay, and what it is not. So a SMART is a randomized trial. Okay, there are randomizations in a SMART, but it's a special case of a randomized trial because it includes multiple stages of randomization. In a SMART, every stage of randomization corresponds to a scientific question that we're trying to answer about how to sequence and adapt our intervention components over time. Okay, so let me show you an example. You remember my hypothetical adaptive intervention? None of you have said that, but this example is rather silly. It is. It assumes that I know everything that I need to know in order to develop a high-quality intervention package, adaptive intervention package. It assumes that the best treatment, the best initial treatment, is text messages. It also assumes that I know how to identify early non-responders. This is correct, by the way. We do know. It also assumes that I know how to treat non-responders, that the best treatment is to add body training. Is it the best treatment? I'm not sure. And it assumes that for responders, the best way to address their needs is to step down the intensity of the text messages. It looks kind of bizarre, right? The assumption is that I know everything that I need to know in order to put together an adaptive intervention. But the problem is that that's not always the case. And just for simplicity, there are many things that are wrong in this example, but let's assume for simplicity that there are two scientific questions that prevent me from developing a high-quality adaptive intervention in this context. Just two questions for now. Let's assume that I'm not sure whether text messages is the best initial treatment. It's low cost, but maybe I need phone coaching initially for supportive accountability, right? It's more costly, but because it involves a human person, a human being, right? It might be more effective. And then let's assume that a second scientific question that I have is how to treat non-responders. Let's assume that I don't know if body training is indeed the best way to treat non-responders. Maybe augmenting the initial intervention with a more costly component, phone coaching, would be more sufficient. Body training is less expensive compared to phone coaching. And text messages is the least expensive component that I can offer in this setting. Okay, so let's assume that I have these two scientific questions. Should I start with text messages or phone coaching? And what to do for non-responders? Should I augment with phone coaching or with body training? So far, so good. These are the scientific questions. You all with me? And you stare at this design and you're thinking, what's going on here? It's very simple because this design is designed to answer these two scientific questions. There are two stages of randomization in this design. Do you see that? 1, R stands for randomization, and 2 for non-responders. You all with me? So to answer the first question, at the beginning of the trial, let's assume I'm randomizing people equally, 0.5 probability to either phone coaching or text messages. And then at week 2, I identify my non-responders, and I re-randomize them to either augment the initial intervention with phone coaching or with body training. I do this in both arms. Do you see that? Yes? Yeah? Okay, let's assume that I conducted the study and I collected the data, and my outcome is again weight loss at the end of the program, and I have 400 participants in the study. Let's ignore attrition for a second. How do I use the data to answer the two scientific questions? And the answer again is by estimating main effects. You see? To answer this question, whether I should start with phone coaching or text messages, I'm going to pull outcome information across all the conditions in which people got phone coaching initially, and I will compare it to all the conditions in which they got text messages initially. You see what's going on here? This is the main effect of the initial intervention component averaging over subsequent components for responders and non-responders. This is like a factorial design. Think about the initial component as one factor with two levels, either phone coaching or text messages. And think about the second factor, about that second component for non-responders as a second factor that has two levels, phone coaching or body training. See that? And you cross them. The design here is restrictive. It's restricted in the sense that only non-responders are being re-randomized. Why? Because the second scientific question was only about non-responders. The assumption here is that I know what to do for responders. You see that? This is why for responders I step down. I know what to do. I'm not randomizing them. But it still can be conceptualized as a 2x2 design. 2 because I cross the first factor, the initial component, with the second factor, subsequent component for non-responders. You see that? So this question can be answered by estimating main effect, and it's basically a comparison between half of my sample versus the other half. So if I have 400 participants in my study, it would be a comparison of 200 versus 200. Yeah.
I totally understand. I see what you're saying, Larry. But this design is temporal component,
yeah.
Right? So the decisions are happening over time, whereas the physical
That's exactly it.
Design, the temporal component is.
You got it.
So is that an issue, or how do people rationalize?
Here it's not an issue, and the way to talk about it, it's like a factorial design where the factors are time varying, right? But at the end of the day, what you end up doing is you end up comparing these two components, averaging, that's why I said subsequent, averaging over subsequent components for responders and non-responders. It's how you talk about it. Things happen over time, and what you end up doing is you average for things that happen over time. And they are being controlled for. They're being controlled for by experimentation, because you know what you're doing for responders and you know what you're doing for non-responders, right? Does it make sense?
Yeah, it makes sense.
Okay. How much time do I have? Sorry.
You have about 5 minutes.
Okay, I'll do that. Yeah, only 5. Can I take 5 more? Yeah, I'll finish up, and then if we have time, if they're kind to us and give us more time, then I can answer the question. I know, so they're kind, but they're not going to give you more time. I'm trying to be politically correct. It always comes out. So the second question about what to do for non-responders, again, can be addressed by estimating the main effect of the second stage component for non-responders, averaging over what happened to them previously. You see, it's very simple. I'm going to pull out some information from all the non-responders who got phone coaching, and I will compare it to all the non-responders who got body training. You see that? Assuming that I started with 400 people and 50% non-response, this will be a comparison between 100 people and 100 people. Basically, this analysis would include all my non-responders, and it will compare half of my non-responders versus the other half. You see that? All with me? Yeah. This is the main effect of the second stage component, averaged over what we did initially. Okay? But I think the data from SMART studies can also be used to answer, in my opinion, scientific questions that are more interesting than just the main effects of the first and second stage components. And I just want to share one example with you, one interesting scientific question. And this question is about the comparison of adaptive interventions that are embedded in a SMART study. And I want to show you that in this study, there are 4 embedded adaptive interventions, 4 tailored sequences of treatment. You see this one? That's the first. Does it look familiar?
Yep.
What is it? That's the adaptive intervention that I showed you earlier, my hypothetical example. It's embedded in this trial. You see? Start with text, that's the decision rule. Start with text messages, step it down for responders, augment with body training for non-responders. You see that? But it's not the only one, there are 3 more. Here's the second. Start with text messages, step it down for responders, Augment with phone coaching for non-responders. Here's a third. Start with phone coaching, step it down for responders, augment with more phone coaching for non-responders. It always scares me. He's been doing some studies where one of the components involved choice, right? So he randomized his initial randomization. This is in the context of alcohol and cocaine dependent patients. In the initial randomization is to motivational interviewing for engaging people in standard treatment versus introducing choice. See? Because he wanted to know whether choice would be better than engaging them in standard treatment. So here, whether you should let them choose or not is a scientific question that you want to investigate as a component in a SMART, in an adaptive intervention. Does it answer your question? Oh, okay, I'm up again. Okay, where was I? So that's the fourth. Start with phone coaching, step it down for responders, and augment with body training for non-responders. And this is an interesting scientific question that I was hoping to, I'm still hoping to answer with the trial that is about to begin. Can you tell me why this is interesting? I kept talking about cost, but I was very implicit about it. Can you tell me why you think this is an interesting comparison? Yeah.
Phone coaching is really expensive.
Yeah.
So you can eliminate the phone coaching much more expensive. Yeah, but wouldn't you answer that by directors on phone coaching?
Yeah. So here's the deal. Here, you're right. The motivation here is to compare the least expensive sequence of tailored treatment compared to the most expensive one. You see this one that start with text messages, step it down, and then augment with body training. That's the least expensive adaptive intervention that is embedded in the SMART study. Do you see that? That's the most expensive one. So I wanted to see if the least expensive support would be as effective as the most expensive sequence of tailored treatment. Does it make sense? But I want you to notice here that despite the fact that now the focus is on comparing embedded adaptive intervention, I'm still not comparing individual conditions, okay? Individual experimental conditions. I'm not going to compare subgroup 1 versus subgroup 4. No, this is a comparison of these two subgroups and these two subgroups, these two conditions and these two conditions. The reason why each adaptive intervention is represented in the design by two cells, two experimental conditions, is because an adaptive intervention, it describes what we need to do for both responders and non-responders. So outcome data from both responders and non-responders, you see here, responders and non-responders will contribute to estimating the mean outcome under this adaptive intervention. So these people in these two conditions were consistent with this adaptive intervention, and people in these two conditions were consistent with this adaptive intervention. And this is my comparison, two conditions versus two conditions. Does it make sense? Okay, I'm emphasizing this because, again, a lot of people, when they see a SMART design, the first thing that they think about is, oh my God, how is she going to do multiple comparisons of all pairwise comparisons of the 6 conditions? But that's not the right way to think about a SMART, right? The way to think about a SMART is like a factorial design, where first you lay out your scientific question, right? And then you design a study in a way that answers those scientific questions. And typically a SMART is being sized to answer scientific questions that can be estimated by comparing chunks of conditions versus other chunks, rather than individual experimental conditions. Does it make sense? Okay, just to summarize, factorial design and SMART design, two experimental approaches. Factorial designs can help us screen out multiple components efficiently and figure out which should be included in our intervention and which should not. SMART designs can help us construct high-quality adaptive interventions that can help us decide what is the best way to sequence and adapt the interventional options, the intervention components over time. Both can be used to optimize your package before you compare it to control. So far, so good? Some useful resources for you if you want to learn more about these designs. If you have other questions, please email me. But if you email me, please You want to get my attention. Never start with telling me, oh, Billy, I want to conduct a SMART, or I want to conduct a factorial design. Can you help me? Start with, these are my scientific questions. I think that a particular design would help me answer them. What do you think? Right? Always start with the scientific question. That's it. Well done. Right on time.